Okay, so today we're going to be talking about friction. So friction is the force resulting from the normal force times the coefficient, whatever you want to call it, of friction, which is always less than 1. But, to start off, the force friction is the result of microscopic teeth, if you want to call them that, on the parts of two objects which want to slide together. Now, friction is always operating in the opposite direction of movement, because no matter what direction you try to push the object, these teeth are always going to be in contact. They're always going to be pushing against that direction. So friction is essentially a mini normal force. No. Give me a second. So the reason why we consider the normal force is that any acceleration that the object is experiencing, say this is our object, any acceleration it's going to be experiencing is going to be pushing these little teeth further into the crevices of the object which it is sliding over. So, say we have gravity, so this is 1 kilogram, so that would be 9.8 newtons. So to make things easy, let's say that our coefficient of friction is going to be 0.5. So by that token, the force of friction is going to be 0.5 times the normal. The normal in this case is 9.8 newtons. So we have 0.5 times 9.8 equals 4.9. But the reason that friction is not always only considering gravity is, say we have somebody using their eyes, I don't know, pushing down on this block. The normal force is going to increase, while the force of gravity is not. So, if they are putting more force on it, the normal force will increase, but the force of gravity will not. But the teeth will still be pushing together more, and so we have higher friction. Now, friction is always operating in the perpendicular to the normal force, and the normal force is always perpendicular to the surface on which it is. So by that token, the friction is always operating in the opposite direction of motion. So say we want to push this block this way, friction will always push this way with the force equal to the coefficient of friction times the normal. Now, as you can see, friction can only operate up until a certain point, because past that point we have pushed the teeth over. Now, give me a second to erase this. So, to overcome the force of friction, that is, to make the object move, we have to apply a greater force than the normal times the coefficient. Otherwise, the object will just stay at rest. Now, once the object has started moving, we move from the coefficient of static friction, to the coefficient of kinetic friction. the coefficient of kinetic friction is almost always less than the coefficient of static friction. Because when we have the teeth pushing together, if the object is moving, the teeth will be bouncing over each other rather than locking together. So while we still have some friction, the force applied by that friction is considerably less. And we all know that from, say, pushing a couch across a carpeted floor, that it's easier once you've got it started moving. And that's because we've shifted from the coefficient of static friction to the coefficient of kinetic friction, which is most frequently less. For example, ice, it's half. So ice static is 0.04, and ice kinetic is 0.03, or 2 rather. That's about it.